So our next presenter is probably someone you know from previous engagements at CSCS. Sadaf Alam is now at University of Bristol, working on a very important system that's just coming up, Isambard. So she's going to be talking about how that's coming about in its containerized environment, as well as work that's coming up in terms of AI for them. So thank you, Sadaf, for joining us again.
Yeah, thanks for the invitation. And yeah, when Hussein said this conference goes back 15 years, I thought I was almost there for 14. And so this is my first conference I'm attending as from Bristol. But of course, I still feel very much part of CSCS. So I knew Thomas was going before me. So I thought he can give almost 50%, if not more, of my talk, because Isambard AI is kind of a, I don't know if I should say it like that. It's very much inspired by Alps. It's kind of a little brother, if I can call it, of Alps. And then I knew my colleagues would be giving a talk later in the day. So I said, what should I talk about today? So I talk about something where Isambard is different from Alps, which is using the container data center. I will touch a little bit what has been done to make it an AI platform using an HPC technology a little bit. But as Thomas said, Alps was designed to incorporate some of those design principles from the beginning because, at that time, I will say in a collective, we were already dealing with some of those situations. So this is the picture of Bristol with the bridge and Mr. Isambard up there. He started it, but he didn't finish it. It was finished, in fact, after that. And Bristol is considered a city of bridges. They have about 60-some bridges, I think, by one account. And the center is a little bit further along. So my talk is split in some parts, but majority of the focus is on the containerized data center because I thought it would be of interest and it is something new. And so I will kind of tell you about the story of Isambard AI because in Thomas' talk, it was really came across things were done in a very structured way, very Swiss way. In UK, this is the first shock that went to my system. Things are a little bit kind of chaotic. So the way Isambard AI came around is in itself a story, which is something when I joined Bristol, it was really not there. And how did the modular data center come about? Again, I call it a series of fortunate events. So most of them were really not planned. One of the things that was really done, maybe a little bit differently from an Alps design, but not so much, was that the University of Bristol, they have set themselves even almost 5-6 years ago, this target of sustainability, like being net zero by 2030. It has some details to it, but that really became like the part of procurement for this system. So I'll touch a little bit about what does it really mean. The other thing that, again, I'm trying not to use any political terminology, lowering access barriers. So one of the things I learned, and being part of very collaborative projects in Europe, is how to use federation. And this is something I think people talk about and they don't kind of practice because it's difficult. So we are using some of these technologies for lowering access barrier, because if you do say federation for the sake of federation, it doesn't work. But I think it's really, really very important that some of the technologies and academic and research communities are connected and they can use each other platform. And what is happening next? So I think a few months after I joined Bristol, the UK government released this report. It was a few years in making. It's called the Future of Computing Report. They realized, again, should have been obvious, but they realized they have not been investing at a national level in computing. And this report, it highlights, and they made a recommendation that in very near future, they should invest about 900 million pounds. So what you see is like a diagram that comes in this picture, and you can see there is, from your left to right, It talks about the usage of exascale computing, the type of users, the type of use cases, and they call themselves pioneers. So you can almost think about, people who will be using exascales are kind of elite in some sense. And what they say were their aspirations was for AI is much more broader. They say, and as I listed it on the other side, they want the AI users and users communities, it should be accessible to all users. It should not be designed. Exascale is important for its own reason, but it should not give this feeling of, almost elitism. You need to really earn yourself to use an exascale system. It should be sustainable, so the way people learn and teach and deploy these platforms, again, these should not be specific to one data center, one environment, one team, one specialization. It should be accessible to all sectors. And I think Thomas highlighted in his slides, the spectrum of users and use cases that are covered in AI are much more broader in society. Like one of the domains that will be largely affected, and especially in the UK where NHS is really struggling in more than one way, they are betting really big on using AI to improve the efficiency, the performance, and the delivery of services. It should have performance for all tiers. So if you are using one GPU or a small number of GPUs, or you are scaling out from inference to training, you should not feel a change in user or usage behavior as you go there. Like, you should not really turn and tune yourself. Now I'm doing training, no, now I'm doing inference, or I'm really exploring this environment. So this was one of the design points. And the last one, even though it's written in a very, very small way, but which is called Sustainable AI Research Resource Program. So in the UK, 2 systems have been announced so far. One is, of course, Bristol AI, and the other one is at Cambridge using Ponte Vecchio, and I can talk offline what this is about, but University of Cambridge and Bristol are working very closely to set up an environment where the allocation, the usage, the data transfer, the training, the teaching, the partnership is done from a user perspective in a unified way. Because that's how you can bring in other sites, other AIRR sites, and that's why you can grow the environment. So keeping this thing in mind, I can tell you a little bit about why we could not use the rigor that Thomas said it was used for building out and designing else, because things had to be done very, very quickly there. So this is kind of a timeline on how Isambard AI came about, and it is almost supersonic. So Bristol had important, in fact, it has the place where Concorde was built, and they had a ceremony there recently. I call it almost supersonic. So starting from 2016, where Simon McIntosh-Smith, who started the Isambard projects using ARM for HPC, at that time it was kind of novel, so he built 2 systems. And at that time, the way these tier 2 systems in the UK, they are funded, you get money for capital, but you have to donate people. So pretty much he never had a dedicated team. There was no Isambard team, like from a system management, engineering, software side of thing. So, and then I said in about March, that Future of Computing report came about, and the UK government said, okay, they solicited which site can do what. And so they ran this solicitation program in around June, July timeframe. And we replied, we said, okay, why not? This could be done because already Isambard 3 could be built. And for those of you who know me, I mean, I'm not going to say I'm reckless, I'm quite ambitious. So we put that proposal, and like 3rd week in August, we received a message from the government, and some people tell me really high up in the government, they said, we wanted to talk about your very ambitious proposal. And I can't go into detail, but again, I can say you why offline it was considered very ambitious. And at that point, the picture you see down there is a car park. So nothing were done, nothing were decided. And then within a few days, they decided that they want to take a, I won't call it almost a punt on Isambard AI. They said this is an ambitious project that can be done and done very quickly. So time was of an essence. They really wanted something to be done very quickly. So in about 4 to 5 weeks, the procurement was written, it was open, and it was concluded. When I tell people, especially hiring, they say, how could you have done it? And there, especially my Alps experience helped quite a bit. The reason it had to be done like that, because the UK government, and especially the Prime Minister, Rishi Sunak, he had announced, so there was no other reason for time pressure, other than I know of, that on November 1st and 2nd, there was a global summit with all the dignitaries and important people from all over the world. They would come to UK for this summit. And there is a picture, and if you can see close enough, you can recognize some very important people there. And these systems had to be announced before that date. You could be lucky. And they gave us money for that part. And again, contractual and other things. So on December 20th, we opened the first hiring. So I can tell you, there was no team at that point. It was Simon McIntosh Smith and I started planning on things. So we started hiring on the December 20th, or didn't start hiring, the post in fact went out. And at that time, they started digging up this car park here, which I will show you later. So even a few months ago, there was no team, no nothing. And in March, as you can already see, the concrete pad was built here. The system, this data center was deployed. It looks like a bit different here. This is a chiller and other thing. And we had a contractual deadline. So within less than 14 days, we reran, in fact, a factory test in here. And as I was telling some colleagues, a lot could have gone wrong at that point because it's the first time all the utilities, all the networking, like everything I used to take for granted at CSCS, nothing was existing there, and it came online at that time. And already now, as we are installing and configuring the CSM, Cray System Management System on this machine, and bringing early users from AI Safety Institute. And this is a picture of CSM training, second week of March in there. So it was, almost dizzying fast there, but can be done. As I said, it is almost impossible, but not quite. So what is the usage of Isambard AI as per government definition? So here you can see this is the department. And it is a relatively new department set up by the UK government because they saw their existing department are moving very slow. So it's called DSIT, Department of Science, Innovation, and Technologies, and these are the people we deal with. Typically for Exascale or other system, they have another department dealing with it. And within that department, they have created a new group. We will go and see them. We talked to them already, but we will go and see them for their early platforms later this month. So it's part of DSIT. And as you could imagine, training large language models is, of course, one of those reasons. Large-scale inference, and any scale inference for that matter, foundational AI research. So UK, one of the things I think, again, from a Swiss point of view is different. They have a very huge network of universities in the country, as well as research institutions. Hybrid AI simulation, workflow, and machine learning. And in terms of the allocation or access, because things happen so fast, it's not been completely defined, so there is a concept paper, but the idea is there will be some strategic allocations and there will be some open calls. And the idea is to accommodate GPU payloads at any scale. So something equivalent to maybe Google Colab, and all the way people going and SSHing and running very large inference job. So now I move to the other thing that I learned from almost zero. And it's good to know and prepare, but sometimes I think you can say, luck also comes to it. So it was really a series of fortunate events when I look back and think about it. So Isambard 1 and 2, the ARM-based HPC systems, It was a collaboration between what they call Great Western Universities, which includes University of course, Bristol, Bath, Exeter, and Cardiff in Wales, and the Met Office, the UK Met Office, about same at Met Swiss, but with a much broader mandate because, as you could imagine, UK has a lot of interest above and under the ground all over the planet. So it's kind of, yeah, but conceptually it's the same. So they had a data center where they will sort of host Isambard there. Now you see this announcement. Like, they announced a few years ago that their big procurement is with MS Azure. And maybe online and offline, you know what is going on there, so we will not go into detail. But what that meant for Isambard is Isambard 3, which is based on Grace processor, could not go into the Met Office data center. So Bristol had to find a solution in terms of data center. Where did it go? And there were different options considered, so I'm just mentioning two here. And Isambard 3 was decided before I joined Bristol, so I can't take it credit, but I was involved in the MDC side of things a little bit. So one option was you could rent some space. That system was not that big, so you could rent a space in an existing data center, first of all. And there are several across the country, but they are usually often very expensive. And when you start building an EX-style system, the amount of, like the density, the power, and cooling, majority of the commercial data centers aren't designed. Even if they kind of advertise themselves supporting direct liquid cooling and other, they go up to 60, 70, 80 kilowatts. So it was not an option. The other one, of course, you can say, like CSCS, build a new one. Planning permission, all these things, I mean, joys, that was kind of not an option because you had to get things up and running in a matter of few months. So they say, okay, containerized. So HP came back and they say, this is an option if you find a site with enough power and cooling. So what is an MDC or modular? So if you know it, it's like really basic. So HPE defines us as a data center that encapsulates everything. Like encapsulates pretty much, if you can think about a CSCS or any brick and mortar data center, anything you do in there is kind of part of a modular data center. And you can mix and match. So if you choose to use our existing cooling, I think that is probably also possible. Because we needed everything from scratch. So we said, so it has all the IT equipment. So it's really like a modular, self-contained, and agile, and it has power equipment and cooler equipment, and HPE defines them as Performance Optimized Datacentre as their marketing terminology. And they define it as a Lego blocks. And the way to think about it is, in your organization, you could have both functional and performance requirements, such as you could think of a high availability zone. And if you build a typically brick and mortar data center, you sometimes end up over or under provisioning something. There you can really provision it down to close to a module. Same goes with security. So you can really put things together as different parts of your business needs and case. And I will maybe show a little bit. There will be parts of the machines that will be, of course, running on what I call dirty power, but there will be parts of the machine which are high availability. So you could have things like UPS, batteries, whatever your heart desires. It could be included as part of the design. The other thing is efficient and flexible deployment. And it's kind of, depends a little bit, but you could imagine between 4 to 6 or 8 months, depending on the level of customization you are doing, you can put an order in and you can get a data center out. It could be, depending on your site's readiness. And I will show a picture. So I went to a site where they are building the Bristol containers in Netherlands, and they showed they are building these things for really very extreme environments, like in deserts and other places. So, or in an environment which is going to NATO or some other countries where you have to really put things in a, where people could be literally bombing you or things like that. So you could deploy them again. We are not deploying anything like that in Bristol. Up until now, I hope there is no need. But these things can be customized from inside and outside both. And the most important thing, which was very important for Bristol, was sustainability. So on the side of day-to-day operation, I was really surprised when I looked at the software side of things they showed me. To me, I'm a software person, so it looked like a very sophisticated software. Of course, it is a data center, but the amount of telemetry you get is just really fascinating. So DCIM, I know we use at CSCS and other places. The level of granularity you get is just fascinating. And typically, the refresh and upgrade cycle is 10 to 15 years. I mean, you can take minus. And I was talking to the company that deployed. I said, how many parts you could recycle? They said, we can pretty much recycle everything except for some few cables or some networking. And while we were at their factory, they were showing us that someone decommissioned a data center and they repurposed it for some other site with minimal effort. So the idea of you do not have to throw away a lot of things as part of your data center was a really exciting part for this design. So this is the site where the Isambard containers will go. It's a national composite center. So it's part of Bristol, but it is as defined center of excellence for composite research and development. And by design, it has about 10 megawatts and more power, network cooling available. So it was a well-connected because people do research of different, and industrial research of different sites there. So I went there, and they showed me where they bake literally a wing of a plane. So it's huge. So this thing spans, if I can show, this is, I mean, if you come to Bristol, it's a really nice site to visit, like the type of equipment they have there. And then this was their car park. And around COVID, like I said, this is a series of fortunate events. Around COVID, they realized their car park occupancy, even after the COVID, was around 50%. It was really not going up. So when we went there as a site review, they said, yeah, we could pretty much give you all of this, and it will not be a problem for them. So in fact, initially we were going to use a very little part of it, but after Isambard 2 is scaled out, we are still pretty much, they call it 4 bays of the car park in here. And if you have seen CSCS data center, it has 3 levels. In this car park, you could imagine all these 3 levels are flattened on the thing. So if you can put I think SEA is doing that, you could probably potentially fit it in that. And one of the other reasons it was very important for us to go there, we are not initially doing that, but you could reuse the heat coming out from supercomputing system quite easily because it's not a very built up area, but it's an industrial area where different industries can start using the warm water there. And then being co-located with NCC, which defines themselves as a digital first approach, is quite important. Okay. Oh. So in a more layout picture, how does it look like? So I'll try explaining again. This is not my field of expertise. But when everything is said is done, there has to be a lot of security that goes around it because there will be more than a couple of $100 million worth of equipment going on there and a lot of power. So this will be the security things there. This is Isambard 3 and Isambard AI phase 1, which is a smaller 168 Grace Hopper system. And this is the whole scale out part. So this is the part where you can see all the transformers and other things will go. Things have slightly changed. This is the data center and hall. So the main hall will have around 5,300 Grace Hoppers, much smaller. And then they have a air-cooled hall for networking, storage, and all the other things. And this is where cooler, pump skid, and all these equipment will go. for the big scale-out system, which is around 5 megawatt. And this is a much smaller one with Isambard 3, which is a Grace system. 2 chillers here, and Isambard AI phase 1. And as you can see, there are ways for trucks to go back in and security and other things. So in terms of what has happened so far, that the phase 1 arrived in March, phase 2 arrives in, so if you go to the site, I'll show a picture, it's dug up already. Isambard AI, in terms of capital investment, including the data center, is around 200 million, just over 200 million. And that includes, like I said, almost everything, including the connectivity. With total operation, people, power, everything is over 300 million for 5 years, around 5 megawatts. Our target is to use PU of less than 1%, and it can happen because Bristol, it rains a lot, and it's usually very cold. So for the most part, almost 98%, it will run on free air cooling. So it will really not have chillers or anything running. And especially if you start using waste heat and other thing, it will be a very environmentally sustainable solution. So this is the picture. No, something different. So I said the factories in Netherlands. I will talk to Joost where that space is. It just looks really like an hour or so drive from Amsterdam. And we went there. So this picture is taken, I think, 12th of February, like second week of February, we were there for a couple of days. And at that time, you can see they were building 2 sites. So it will come together on site and sealed. So it's built and shipped like that. So it's shipped in 2 separate parts. And this is the initial air-cooled part of Isambard 3, which was then later fitted for a DLC cabinet, so you can still see a lot of fans here, but the system that is entirely built for DLC, it will look slightly different. So, and then they have places for all the other things. People who know data center much better can probably, so it was really fascinating how they were building these things very quickly. So in like less than 4 or 5 weeks, from this, you have a system running almost 7 petaflop on site there. So this was kind of fascinating there. You can see like a Hoover and other thing. It was a very busy site. Okay. Is it not working? Am I too far? Or I ran out of battery. Okay, let's just do that. So fast forward 4 weeks almost from that day. This is the Isambard site, and you can see crane, and the 2 gray things are the 2 sides of the the data center you saw in the factory, and they came packed and wrapped. From Netherlands, they were driven on trucks. And you can see a crane that was going to go in there. So that picture is taken on March, I think, 12th. You can see pretty much an active site there. And they had to delay the, placement of the data center, because Bristol being Bristol, that day when the placement was planned, it was raining and it was quite a bit windy. And they couldn't do it because in order to seal both sides, it had to be completely dry. So the risk for placing them in a rainy and windy day was very high. So we waited 1 more day, and then, in fact, that day it was still quite windy. So they had to have people holding on to it so it doesn't start spinning. It's like pure adrenaline, I call it. 2 days was really, I still have my fingernails. It was really exciting, but really nerve-wracking at that point. So yeah, this is the picture. I thought I didn't have it. So on 15th, when we took this picture, so it's arriving after a few days, this was, as you can see, tucked in there. There is another chiller now in Palm Biscuit, and all of these are deployed here. And these were like really deep trenches dug up in there. where we get all the utilities power and cooling from the NCC data set. And I will show a picture there. So this is where now the Isambard 2 will go and be completed there. So this is the site on 15. So in matter of 2-3 days, they installed it, they sealed it, dried it, and it was ready to get pressurized and energized, as they call it there. So there are some Isambard first and my personal first, which I will say. Sometimes it's good to, but so HPE told us that this is the first container data center they built where they will put EX DLC systems. So it has never been done before. So I didn't know that before, otherwise I would be even more anxious when they were doing it. And this is, in fact, their first deployment and power up in less than 2 weeks. So with modular data centers, I was told there are 2 options. Sometimes they build and pack, do everything, including putting the computer inside the data center in the factory, and they just bring to the site and plug it. But because this was built in a partly built off-site and then partly built there, they said this is for them like also something that was not done before. And when they build the complete scale out, it will be the first containerized data center with both directly liquid cool hall and then the other cool. And this is one of the things I can maybe highlight. I think this is the EX pictures. Because this data center was designed for Isambard 3, which is a Grace system, smaller, and with normal size cabinets of HPE, not EX, they said they had millimeter clearing to slot this EX 2500 system. So it took them almost 2 hours to kind of gradually slide the cabinet inside the data center. That was kind of really fascinating. For my personal first, and I don't know, at CSCS, I don't think I ever, or at Oak Ridge, I ever had a hard hat. You wore a hard. So because I was on an active side for running benchmarks and other things, you can see me. I was working high vis and like personal achievement of sorts. And as you can see, the system is very, there are essentially 2 cabinets or third one there. So there is this, so this is inside. It's a very functional. So CSCS data center is really for showing off and telling people, dignitaries. This is a very much work-like data center. So we have to be very careful when we bring people in, because it will be totally underwhelming. Because you will be just squeezing it to do the work. So it's for people to do work. It's not for people to show off. It could good look on the taxpayer side that we are not wasting taxpayer money. And so this will be filled. So this is inside the data center, and when EX cabinets come out. So let me just check the time quickly. I think we are doing good. So again, in our community, we get through the hypes. And so Simon, when he was, and I think Thomas was also at GTC, because I saw his talk, the GTC was like totally packed. So there is a big hype around AI. But one thing we know for sure, unless things are stabilized a little bit, you need a lot of compute power. So the idea is, how do you do it in a sustainable way while you initially, once it gets into some steady state and optimized state, it will require a lot of computing power for AI. I think you probably heard about this thing that they say AI is kind of a killer app for Exascale. So University of Bristol, as I mentioned earlier, they have a target to meet their thing. And when this project came about, there were more than a few challenges for Bristol. They have never done a project like that before. They have never done a project like that at this scale and that fast before. And universities, they change in decades or centuries. These are old established organizations, and if you tell them to make a decision on a few $100 million grand in 3 to 4 weeks, their system just breaks. And then one of the things that were really also very challenging for them. They set themselves this goal for net zero target by 2030, and building like 5 megawatt plus system would completely, you can say, change that. So we had to engage with the sustainability team very quickly, and that, I think, as a whole, improved the project. So it was in the procurement document, in the implementation, in the engagement side of different parts of the university and beyond, with the national grid, we had to engage with each and every stakeholder while writing the technical procurement at the same time. So we set ourselves a few optimization targets. We said, for the most part, the system should design to work with free air cooling, and then the way the power PUEs kind of target. There are other targets in details which we can go. We should really aim. We set it for, in procurement, we can't write it like that, but our idea is to run it at 1.07, if not even better. That's our. And then the carbon usage effectiveness. So that's where the engagement with the local power grid was very important. We said we really want to choose the fuel sources. There is a lot of nuclear also in the area, so non-fossil fuel sources. And as soon as we are done with the main deployment part, the idea is to reuse all the heat generated by the system in the so this is kind of part of design. The other thing that we ask the vendors to provide is, can I ask how many of you are familiar with this scope 1, 2, and 3 target when it goes with carbon emission? This is really, it's interesting, but quite boring. But I can say very quickly. So scope 1 is something you generate as part of your running service. So it's not zero for us, but almost zero, because there is some sort of a diesel power generator for running UPS for graduates. So we do generate some emission through this diesel generator. So it's not quite zero, but it's less than 1%. Scope 2 are really what you take out from, like, someone who provides you fuel, their carbon emission. And considering everything, it will be for the whole lifetime of Isambard, it will be around 90%. Scope 3 is very interesting and very difficult, because it talks about the entire life cycle for producing a chip, producing a component, shipping it to site. And it's there are no specifically standard to measure it. But HPE, they did their best to provide us that estimate that each and every component, what would be that scope 3 emission. So it right about works on 10% of that. And then there is a reference to UK data, how then you actually measure and compute it for the carbon emission. So this is roughly what we calculated, and these are detailed, and these will be monitored and reported for us. The other very interesting thing was that we asked, of course, the supplier to tell us how, after the decommissioning, how would you sort of dispose of his stuff. So I think up in Scotland, they have HPE as a recycling, so they imagine almost up to 95% of IT, and even more of the data center could be recycled end of the life. So I think these are the important things. Here I can be maybe quick, because I think Thomas covered some of it. The other thing which was part of the design, because the first thing, and no criticism to Nvidia colleagues, they say, we know AI, and you buy our DGX system. That is AI. I said, no, that doesn't happen. So, because and the argument for me was very simple, because I knew this could be done in that way. And the other thing was, we were very limited on space. So if I had built a DGX system, by any estimate, you put, like, God knows how many racks on the thing, so we would be needing more than the car park. So we chose HPEX solution, DLC, all-level compute networking, and then Grace Hopper for the design principles also. I think Thomas mentioned already this NVLink and the performance and power efficiencies over I can't tell you how many calls we had. Why you are not building an x86 and a dense GPU system still today? This is fascinating. Of course, HPEX solution is an HPC solution. You have to do more to build an AI platform out of it, which I know the technology exists working with CSCS, and we have to do a bit more. But it's much more fascinating and exciting building an AI platform in a co-design way with the community rather than just plugging in a DGX and calling it like that. I think Thomas showed it, but I can very say. So this is the individual chip. The specs are shown there, and how it is connected. So when we talk to the AI community, their imagination is sort of almost frozen what a compute system is. And as Thomas almost highlighted, when I tell them you can fit in almost any model that is around 1 terabyte, their eyes light up. They say, yes, can I do it? I say, yes, written there, but of course you don't want to say it like that. So you have to go through detail and tell them, you have a single address space almost for fitting big model. So we have some work to do in co-designing. It could not have been co-designed in the way, of course, Alf was co-designed. So it will be co-designed with the AI safety and AI platform communities. And I'm pretty confident if I come next year, I can say how successful it is running as an AI platform. But like I said, I'm pretty confident it can be done. The other thing, I know it's an Nvidia kind of sort of event since about SlingShot. Network, there are very, very, how do I say, firm ideas what is an interconnect for an AI system. And this is a rather old picture. I will probably ask HPE for a newer one. So the interconnect in EX Alps is SlingShot. And it was designed many years ago, and it's still, like I said, being hardened is the right political way to say it. It is bringing the more interoperable standard components of Ethernet, but at the same time bringing in low latency, congestion control, and other features of HPC. And it is both from a hardware design point of view, system stack, software stack is really like co-design. And the other thing that is, for us, was important that even the network is kind of liquid cooled. So when I, for instance, learned about how Dawn, the other Ponte Vecchio system, has been designed with InfiniBand, they have like racks and racks to connect their 1,000 Ponte Vecchios. This one is going to be really, neat and compact. So if I was not giving a talk where a lot of CSCS talks were, I will go in more detail here. And here, I'm really trying to, just gloss over here. So how do you build a high-performance, cloud-native software ecosystem for AI platform? Because majority of our AI platform, and this is something really different and almost unknown for me personally and for like people working in this area. Building a life cycle upgrade of an existing machine, you know your community. And you know what they will do and majority of what they are used to and some new. The AI communities we are bringing, most of the time they are working on with their local systems, under the desk or something, a dense system. And sometimes they are working really on public cloud, which are getting more and more expensive by the day, as they tell me. So when they come to AI, they cannot just be simply happy by having an SSH-only access. They have to have the environment, and I don't want to kind of make it sound like they want a Jupyter notebook only. There is more to it. So the idea is, how could you create different tenants which can take different personas for people coming in? So in this picture, this is, and both CSCS and me also, HPE has a cloud-native, microservices-based architecture. Again, like SlingShot, it's being hardened, if I'm trying to be politically correct. But the idea is that you could deploy different as-a-service model, which you cannot deploy in a very classic is the wrong word, legacy is the bad word, in a classic, typical HPC single integrated environment. And this is the picture. It will look like very much like the V cluster, and I will be working very closely anyway, and we are working very closely with CSCS. So on the 168 GPU or 14.2 node phase 1 system, we are already setting up 3, currently we are calling them soft tenants, because already you need to kind of provide a stable environment so people can start going and running. So our initial 2 will be Slurm and interactive compute, and the other 2 we will continue evolving for co-design. So you can already see there are 3 tenants, and this is the part of the design. I think it ran out of battery. I probably pressed too much. So the initial multi-tenant setup is part of, and all these ideas, before leaving, maybe crazily, we were working on Isambard, CSCS before. So in the last part, and I think this is very kind of important from a different perspective. So we know how to design high-performance computing system. We know how to operate these high-performance computing systems, but we are not very good about bringing the communities who are not typical users to our environment. And this is the task in AI, so I was really quite happy about it. So federation and single sign-on, and I must say, so this is the learning that I have done as part of EuroHPC Lumi project and as part of Phoenix, which is another European project. You could create these federated identity management systems with existing contracts, I should call it, which is again. So my access ID, which builds on top of Phoenix AI, we are using first time in UK, and I'm getting a lot of traction there. So this is and people say, oh, but in that case, you can dilute identity vetting and other things. This is absolutely total misconception. You could, at a service level, add any type of multi-factor, any type of tokenization close to an access level. So I'm showing like a cartoonish picture which was presented at the JISC is kind of equivalent to Switch. So you can think of, I'm very much working closely with Switch AI. Because from a user point of view, we want to provide a self-service cloud-native portal where they can go and they can, within the same session, launch, for instance, any web-based thing like Jupyter. And it should be a single pane of glass for accessing all of their services. That's our target. Another important thing, and I think that's where we worked on, I think I remember even the PSI project. So how do we improve user and usage productivity for the community which have not been using our environments and system? So again, at a high level, what are the ML ops workflows? So ML flow is the one, I think, Stefano Schupli or Jos probably will talk about it. And Kubeflow engines, how we start running them as natively. I think the only thing maybe slightly different with Isambard is there is a large software, in addition to Lustre, there is a large software-defined storage platform. Interactive with Jupyter, I think that is going to go on. People from Bristol are working closely with CSCS. And that's where I found an article from Google Hypercomputer. And when I was reading through it, of course, they don't share much detail. So they mentioned 4 usage patterns. I removed inference from there for the operational part. There is an experimentation period that users need where you run short period, large capacity, interactive types of job. There is training where you run long period of jobs, and then there is fine tuning when you run. And then there is an operational part I don't mention here. So we will have to provide some of this on Isambard AI, and they use 2 terminology, flex start and calendar mode. So flex start, I know I'm making maybe shortcuts here. HPC Slurm batch, you kind of you have a tolerance for starting something late, which fits very well with large training job. When you are in that phase after doing the first phase, because you need so much resources, you can wait for the start time. And calendar mode is something where you can almost make a reservation for a tenant or for a certain resources. And it needs automation, so you don't need to call a sysadmin to do that. And for 1 and 3, we can set up these calendar mode where people can be, they know they have dedicated resources. And I would argue for us in our environments or like ALS, these are much simpler to implement, because in a public cloud environment, you have to find a region, you have to find a data center where you have all the network connectivity and storage close by. Those parameters are not really important for us. And CSCS has done the calendar mode. I know because I was part of it. Again, I'm just checking, so we have some time for questions, so yeah, I can talk about it. Cybersecurity and role-based access controls. So when we were writing these procurements, and still, our IT services were massively nervous at Bristol and everyone else, they say, this will be such an important resource, it's a national resource, and the UK legislative requirements are changing, how do we protect it? For the most network and cybersecurity, don't turn it on, then they will feel very good about it. But that's not an option. And then they say, who will access it? I said, oh, it's for open research community, so people will access it. Oh, so we will not know them. No, we will not know them, because they will be dedicated environment. So as we speak now, the access models and the threat models are being defined, so I'm not going into detail, but the reason I'm mentioning it here is, right now I talked about open access, federation, another thing, but this will really sort of coexist in this very tightly controlled, where we are almost legally binded to provide some information. So when we are providing platform-based services, so initially Isambard AI will not provide infrastructure as service other than the one managed by the Isambard team. It's just because I think by the time I will be done talking to some of these compliance and security people, I will retire. So I said, let's start platform as a service and software as a service. So in CSM, and CSCS had a huge influence in designing tenant and partition management system. We will leverage some of that as part of it. We will use isolation and tagging with the SlingShot. For some sensitive workload, we are not going to put them on Lustre. There is a large enough VAST in there, in addition to Lustre to do that. And as I said, right now we will stop non-Bristol access at infrastructure as a service level as part of that. And this picture here, I think it's probably dated, it should look a bit different, is the CSM, this Discrete System Management, Identity and Access Management, which we are leveraging already. So the final slide almost. What is happening next? So what you see on phase 1 is all done. The system came, it's been deployed, up and running, setting up the tenants. We will get our AI Safety Institute and early users. It's kind of nerve-wracking, but done. Phase 2 is coming out. It's going to be a big scale out. The main difference there is this software-defined VAST storage that I'm pretty excited about. We will start doing some work with the earlier one with a smaller version. I know CSCS is already doing some work. And there we can really look at some of the use cases which we cannot put on the other part of the machine. So, in not too distant future. So I showed you the slide earlier on. And so there is a time-lapse camera on the side. I don't know why, it only takes pictures like 5 working days. So this is the one I took late evening on 12th, because Brian asked me to send slides on 12th. I sent him 13th, so just 1 day late. But at least I sent you, Thomas didn't send you anything. so this is the side. So as you can see, the system on the other side is already up and running, and it is being, as you can see, wrapped up now for security with the little door up there. and everything else is now dug up. So the idea is around July timeframe, they will start building the concrete pad and other thing, and then later on the system will come. So it's happening really at a dizzying speed. And that's it. So what you see, so that is the document that came out after this summit in November, this high-profile summit, and they call it Bletchley Declaration. So at CSCS, I've always been used to, with Thomas and the colleagues, co-designing infrastructure and building infrastructure over a long period of time. In this thing, there was just no time. So I am really, really very keen to, work on the colleagues all over UK to really tune, design, and calibrate for the purpose the system is being built for. So stay tuned. That's it.